Hey folks, welcome back. Hopefully all of you were able to follow along last week with the examples and get your first C++ programs up and running. We're going to continue our introduction to C++ today with arithmetic operators and variables. Then on Thursday, we'll learn about constants and how to use variables in our arithmetic operations. So, most of the programs you'll write, whether it's for network administration or game programming, will need to do some sort of math. C++ provides built-in arithmetic operators, and you'll find that most other programming languages, if not all of them, do the same thing. For adding, subtracting, multiplying, dividing, the arithmetic operators are pretty much what you'd expect. You've got the plus sign for addition, the minus sign for subtraction, the asterisk for multiplication, and the / for division. Now, C++ also provides an arithmetic operator you might not have heard of before. That's called the modulus operator, which is signified with the % symbol. A modulus operator returns the remainder of integer division. For example, 7 divided by 3 would return a remainder of 1. So the modulus of 7 divided by 3 would give us 1. Now let's see how that works by turning your computer into an expensive calculator. I'm in my text editor here, and I'm going to create a program. It's called Expensive Calculator. And I'm going to go ahead and save this. Create a folder called Week 2. And I will name this file expensivecalculator.cpp. Okay. And just make a note for myself that this program demonstrates our built-in arithmetic operators. Okay, we're going to include IOStream. Sorry about that beach ball there, not sure what was happening. Just to save ourselves some typing, we'll use the standard, the std namespace, and we open up our main function. So we're going to see out, and we want to actually display the text of what mathematical problem we're doing. So we will send this text string 7 plus 3 equals, and then a space, into cout. And then we will also send the actual math value. In order to do the math, we just type in 7 plus 3. Notice I don't have any quotation marks around this. In this case, I want C++ to actually do the math for me. So I leave this out of quotation marks. That way the program knows, okay, this is a value that I need to do some type of manipulation on. And then we send endl to end our line. Okay, we'll continue with 7 minus 3 equals end line. Next, we want 7 times 3. End line. Next line, we've got 7 divided by 3 equals 7 divided by 3. And now we're going to write that a different way. 7.0 divided by 3.0 equals, and you'll see why we're going to do this when we run the program. End line. Okay, let's include our modulus. 7 modulus operator 3 equals and I see that I left out some code here. My operator. Now let's try something a little more complex. 7 plus 3 times 5 equals 7 plus 3 times 5 and L. And one more. Let's use some parentheses. 7 plus 3 times 5 equals end line. And finally, we'll return 0 to exit our program normally. I will close my main function, save my file, and now let me get into the correct directory. Okay. I run g++ expensive underscore calculator.cpp. And run a.out. Okay, so let's take a look at what we've got here. As we take a look at the results, they're mostly what we would expect. 7 plus 3 equals 10, no surprise there. And 7 minus 3 equals 4. 7 times 3 equals 21. 7 divided by 3 equals... Oh! Now, if you know your division, you know that 7 divided by 3 does not equal 2. It equals 2 and a bit more. The reason this happens is, a $10 calculator will show us that fractional value. C++ doesn't here, and this is the reason why. In our code, we specified the integer 7 divided by the integer 3. C++ assumes, if all you use is an integer, it assumes that you don't want to keep that fractional part of the result. If you want to get that fractional part, at least one of the values has to be a floating point, a number with a fractional part. That's why in my next line of code, I put 7.0 divided by 3.0. That way, I get 2.333333. The compiler does truncate that value for memory management, as well as just because that would be an unending line of threes. It would just go on and fill the screen. So we cut it down to basically 5 decimal points, which is that's pretty precise. Okay, next line of code, we see our modulus operator in action. The modulus of 7 divided by 3 is 1. After that, let's take a look at how C++ decides what order it's going to process arithmetic expressions. Now, Just like algebra, C++ evaluates math expressions from left to right, but it does give certain operators a higher priority than others. If you remember your order of operations from math class, this will make sense. If you just think, please excuse my dear Aunt Sally. The P is for parentheses, the E is for exponents, which we haven't learned about yet. M is for multiplication, D is for division. Those get processed in order from left to right. A and S is for addition and subtraction. Again, they get processed in order from left to right. So let's take a look at this line of code. 7 plus 3 times 5. Okay, multiplication comes before addition, so the first thing that our program does is calculate 3 times 5, which gives us 15. Then add 7, which gives us the correct value of 22, using proper order of operations. If we want our addition or subtraction to take precedence, we use parentheses. That's why in this line, we have 7 plus 3 in parentheses. That will get processed first, gives us a value of 10. Then our multiplication. So 10 times 5 gives us 50. If you take a look at Appendix B in your textbook, you'll see a list of the different C++ operators along with their precedence levels. Okay, so let's move on to variables. A variable represents a piece of your computer's memory that you set aside to store, retrieve, and manipulate data. It's a box, if you will. You label the box so you know what you're putting inside it, and then you put something related to that label into the box. Now, the boxes we're going to be creating here will only hold one item at a time, but later on we'll learn about a box that can store a whole bunch of stuff at one time. So in C++, we have different types of variables, different types of boxes. Each type can store a different type of information. The fundamental types, the ones that are built into C++, include bool, B-O-O-L, for a Boolean value, which is just true or false. We have char, C-H-A-R, for a single character value, like the letter A, the letter D, or the letter X. We have int for integers, float for single precision floating point numbers, and double for double precision floating point numbers. Now we also have modifiers in C++. These can alter the variable type. For example, short reduces the total number of values a variable can hold. A short int can hold integers ranging from negative 32,768 up to 32,767 on the positive side of the number line. Without that short modifier, our int can hold integers from minus 2,147,483,648 all the way up to positive 2,147,483,647. So why would we want to limit how much our variable can hold? Well, for memory usage, we want our program to use as little memory as possible. If we know we'll never have a value greater than 32,000, it makes sense to use a short int and then save that memory space for something else. Now, there are more modifiers and more variable types than what I've discussed here, but this is a good start. So to demonstrate this, we're going to write a program that stores the game statistics for a space shooter game. What we want to keep track of is the player's score, the number of enemies that player has destroyed, and whether the player's ship has its shields up. So I'll go ahead and create a new file. I'll go ahead and close my calculator. And I'm going to save this as game stats, game_stats.cpp. We're going to learn about declaring and initializing these variables. Declaring it is one thing, but you also have to initialize it. You have to put something in it, and then later on change it, which we'll talk about later on in the class. Okay, once again we include IOStream, and to save ourselves some typing, we will use the namespace std, and go ahead and open up my main function. Okay, so I want a player score, and that'll be an integer. And I'm going to allow my player to possibly get a very high score, so I won't use a short on this integer. I'll just use a regular integer. Distance, I want to be really precise, so I'll use a double. And I also want to have decimal points here, so I have a double, then just a single character, play again. This variable is going to ask the player if they want to play again, which only requires one letter, Y or N. Y for yes, N for no. So we don't need to bring in a full word. All we need is the character. And we'll have a Boolean value, true or false, 0 or 1, are the shields up. Okay, I'm going to do a short, and here you'll see that I'm declaring two variables that are both shorts, lives and aliens killed. I can do that by separating them with commas. I can declare multiple variables of the same type on the same line of code. I just have to separate them with commas. So I've got a short that will store the number of lives the player has, and then another short that will keep track of how many aliens the player has killed. Now I'll go ahead and initialize. I'll set my variables. In order to initialize a variable, you use the equal sign. Okay, so we're going to assign the first value of 0 to our score. Okay, and that just sets our very first value, so that as the game goes on, we'll rewrite what's in that integer score to provide a running tally of what the player's score is. Distance we'll set to 1200.76. Play again. We'll go ahead and set this as Y. Shields up we'll set to true. Lives we'll set to 3. And aliens killed we'll set to 10. Okay, now in the course of our game, if we were writing this full game, we probably would not set aliens killed to 10. We would set it to 0. And then we would increment aliens killed as the player killed more aliens. Just for the sake of brevity and because we're not at the point where we can write a full-fledged space shooter program, all we're doing is our statistics. So we want to give it some information just to display. Now you notice that I'm naming these descriptively, okay? And we'll talk more about that in a minute. Engine temperature, 6,572.89. Okay, so now we're ready to go ahead and return our statistics. we want to make sure that this first line of our stats starts on a new line. And so we put /n, that stands for new line, before the word score. I could probably, in this case, go without it, because I'm pretty sure that this would start on a fresh line. But in the course of programming, you may find that you've got other text on the screen, and you want to make sure that you hit the new line. So we go ahead and declare a new line. Okay, so after score, after the text score, then we'll go ahead and display our variable score, and then end the line. We'll get our distance, whether the player is playing again, and we're going to skip displaying shields up because you don't generally print a Boolean value. And this would either return true or 1, which might not make sense to the player. We would have to write code that would instead put yes or no instead of true or false or 0 or 1. Alright, next let's display how many lives the player has. And how many aliens the player has killed so far. Oh, made a minor mistake there. End that line. Okay, so you notice that so far we declared all of our variables at the top of our main function. We don't have to declare our variables there. We can declare them right before we use them. So let's go ahead and declare a variable called, an integer called fuel. And now we're going to get some input from the user. We're going to ask them how much fuel, okay, the first part that we're sending to cout is the prompt for the user, okay, and we're not going to end the line there because we're going to leave some space for them to give us a value. So now we're using a command called cin. This is going to accept input from the user, and you see from our operator we are funneling the input from cin to our fuel variable. And then we'll display that value. Now we're going to create an unsigned type. Okay, we're going to define an unsigned variable type, which is a short integer called uShort. Okay, typedef says that we're going to define a new variable type. the variable type that we're giving is an unsigned short integer. So this is going to be an integer that's short. It doesn't accept the full value of 2 billion whatever. And it's unsigned. That means it will only be a positive value. There will be no negative sign for this. What this does is it allows us to have a short int that accepts values up to 65,535 instead of going from minus 32,000 to positive 32,000. Okay, so we're going to name this type uShort, and now we're going to declare a variable. uShort bonus equals 10. And in this case, we have declared our variable and set it, assigned it, initialized it in the same line of code. You can do that as long as you know what you want that value to be from the start. You can go ahead and put it there. And now we'll go ahead and display the bonus. End our line. Finally, we'll return 0 to exit our program and close my main function. I save my changes, and now I'm going to go ahead and compile game stats.cpp, and it compiled cleanly. So let's go ahead and run a.out. And there you can see what we get. Score 0, distance, play again, lives, aliens killed. Now you notice that the program has stopped. It's waiting for me to input some values. So I'll go ahead and put just a random number, hit enter, and then it continues. It displays the amount of fuel and the bonus. Now let's run this again, and let's see what happens when I put letters in. We don't get an error, but it doesn't know what to do with it because we've put in letters instead of numbers. We have not put in an actual integer, so it just keeps it at 0. Now, when you declare a variable, you notice that we've used some common descriptive names here. For our score, we've used score. For distance, distance. You should make your identifiers. Now this name of the variable is called an identifier. You should make your identifiers descriptive, but we do have a few rules that we have to follow. First of all, an identifier can only contain numbers, letters, and underscores. No spaces, no special characters, so you can't use the exclamation mark, the @ sign in your variable name. Next, an identifier cannot begin with a number. It has to begin with a letter or an underscore, but we'll talk later about why it's not a good idea to use an underscore. And finally, it cannot be a C++ keyword. Now that's a word that C++ reserves for its own use. We can't name a variable int because that's a keyword. You can find a full list of the different C++ keywords in Appendix C of your textbook. Okay, so we've got a few hard and fast rules for naming our variables. There are also some guidelines that you should follow to create good variable names. The first one is use descriptive names, like score instead of just the letter S. Now, if you're only using the variable for a brief period, then a single letter variable name like X would be okay. Second, you need to be consistent. If you start off writing multi-word variables, multi-word variable names using the underscore, stick with that. If instead you use camel case, where the initial letter of the second word is capitalized, stick with that. Third, you need to follow the traditions of the language. For example, most programming languages have a tradition that variable names always start with a lowercase letter. Another tradition is to avoid using that underscore as the first character of your variable name, because the underscore quite often will have a special meaning for a variable. And finally, keep the length of your identifier in check. Yeah, player 2 bonus for round 1 is descriptive, but it's also hard to read. Try to keep your variable names under 15 characters. Okay, so that covers the first part of the week. Check back in a day or two, probably on Thursday. I will post the next video where we will use constants and we will use our arithmetic operators in with our variables. So if you have any questions, I will be in Sharon Hall 317 on Tuesday. That's tonight for me, from 6 to 7 at least. We're still working on where my office hours are going to be, but I will at least be there from 6 to 7 tonight. So if you're having any questions or problems, come on in and we'll sit down and talk about it. Otherwise, send me an email or give me a call, and I'll talk to you later.